So imagine standing in front of like a hospital board, right?
Okay.
And you're telling them that the secret to completely wiping out their massive patient backlog while, simultaneously saving them something like $7.5 million has absolutely nothing to do with hiring more doctors.
Which is, that's exactly what they're going to expect to hear.
Right. But instead, you look them in the eye and tell them they need to study how Toyota builds a sedan.
I love that example. It's so good.
It's wild. Anyway, welcome to the deep dive. For you, the learner listening right now, today we are taking this massive stack of operational manuals, supply chain texts, and APICS certification materials, and we're just going straight into the engine room of business.
Yeah, we're getting our hands dirty today.
Exactly. We're decoding how organizations rigorously measure their performance, cut the fat, and break through bottlenecks to basically just run smarter.
And, we're doing this because an operation is an operation, regardless of the industry. Like, the physics of workflow apply just as much to a hospital as they do to a factory floor.
Right.
So if you're tuning in, you probably already know the foundational ideas of supply chain. You know Toyota revolutionized the world. But today, we really want to look at the actual mechanisms.
The nuts and bolts.
Exactly. We're going to construct a sort of theoretical three-line. Imagine a highly complex, slightly broken system. Maybe it's a sprawling manufacturer or, like you said, a regional health network.
Okay, I'm picturing it.
And we're going to walk through the exact toolkit required to diagnose its illness, stabilize it, and then optimize it to the point of, near perfection.
I love that approach because to fix a broken system, the absolute first thing you have to do is figure out if you're even looking at the right vital signs.
Yes, the metrics.
Right. And our sources hit really hard on the distinction between a regular metric and a key performance indicator, or KPI, because the trap so many companies fall into is that they just track everything.
Oh, absolutely. The endless dashboard.
Yes. Dashboards with literally hundreds of metrics, and they think, oh, we're so data-driven. But all KPIs are metrics, while very few metrics are actual KPIs.
Because you get what you measure.
Exactly. A KPI has to be brutally limited. The texts say, no more than 20. And it must tie directly to a strategic goal. It's kind of like personal health tracking. Like a metric is just knowing how many steps you took today. That's fine to know. But a KPI is your actual blood pressure when your ultimate goal is heart health.
That's a great way to put it. It's the difference between just, interesting data and actionable intelligence. If we connect this to the bigger picture in supply chain management, you might track dozens of little operational things.
Right.
But your KPIs need to measure strategic attributes, things like velocity.
Which is the speed of transactions, right? Like proving your response times are actually dropping.
Exactly. And the other big one is variability, because variability is just the silent killer.
Oh, like the bullwhip effect.
Yes. If you're tracking the bullwhip effect, where this tiny little fluctuation in customer demand causes massive panicked over-ordering further up the supply chain.
Everyone just hoarding inventory.
Right. That variability is a KPI because it completely destroys your strategic stability.
And what's really fascinating is how dangerous a poorly chosen KPI can be. Like, it literally creates siloed thinking.
Oh, 100%.
Think about a warehouse manager. If their performance bonus is entirely tied to minimizing their specific holding costs, what do?
They stop ordering.
Exactly. They delay ordering, they buy in weird bulk quantities just to save a few cents, and their individual spreadsheet looks phenomenal.
But the rest of the company is suffering.
Yes. Their cost-cutting stars the production line. The rest of the supply chain stocks out of products, and the company loses millions in sale. They literally achieve their KPI by actively sabotaging the business.
Which is exactly why the texts emphasize the balanced scorecard. You just cannot measure a system purely by financial metrics.
Because they're backward-looking.
Yeah, they're lagging indicators. They tell you what happened last quarter, not what is actively breaking today. A true KPI framework looks at financial performance, sure, but it balances that with customer considerations, internal business processes, and the organization's growth and learning.
Right, because if your warehouse costs are low, but your customer satisfaction is just plummeting, your system is failing.
Exactly.
So, okay, assuming we've fixed the dashboard and we're finally measuring the right things, the next phase in our system's life cycle is figuring out how to actually improve those numbers.
Which leads us into total quality management.
Right. TQM and continuous improvement. Now, obviously, TQM requires total organizational involvement, from the CEO all the way down to the shop floor.
To ensure quality of conformance, meaning zero defects, and quality of design.
Meaning the customer actually wants the weird features you built.
Right.
But the benchmarking section of the sources is where the real actionable stuff lives for me.
Because benchmarking is how you define what better actually looks like. And the sources break it down into two distinct approaches.
Yeah.
There's competitive, and then there's best in class.
Okay, let's unpack competitive first.
Competitive benchmarking is just looking directly across the street at your rival. The classic case they use is Ford looking at their accounts payable department.
Oh, yeah. This story is wild.
They had, I think, 500 employees pushing paper, so they benchmarked against Mazda, expecting maybe a 10 or 20% difference in efficiency.
And Mazda had what, like 400 people?
Mazda was running their equivalent department with 5 people.
5! It's just mind-blowing. And the takeaway there wasn't that Ford's employees were somehow 100 times slower. It forced Ford to realize their entire fundamental process was broken.
Exactly.
By completely redesigning how they process payables, they slashed that department from 500 down to 75. Like, they didn't just yell at their people to work faster, they eliminated the actual work itself.
Precisely. But here's the catch. Competitive benchmarking keeps you trapped within the assumptions of your own industry.
Right, which brings us back to my opening hook, the hospital.
Yes, best-in-class benchmarking. This requires stepping completely outside your sector to find the absolute ultimate standard of a specific process. Virginia Mason, that healthcare provider in Minnesota, they didn't look at other hospitals to fix their endoscopy clinic.
No, because other hospitals have the same bad habit.
Exactly. They looked at Toyota's assembly line.
Because, I mean, why would a doctor's office look at a car manufacturer? Aren't those entirely different worlds?
You'd think so. But to your point earlier, the physical movement of a patient through a clinic, the intake, the waiting room, handing off to the nurse, the procedure, the recovery.
It's just a flow of value.
It is functionally identical to a car chassis moving down an assembly line. Virginia Mason applied lean manufacturing principles, and in the first year alone, they saved $7.5 million.
And they wiped out their patient backlog.
Without sacrificing a single minute of actual doctor-patient time. They just eliminated all the wasted time in between.
It's brilliant.
And sometimes, you don't look at another company at all. The texts use the Roger Bannister 4-minute mile analogy.
Oh, I like this part.
Yeah, for decades, experts believed the human body was just physiologically incapable of running a mile in under 4 minutes. It was considered a hard biological constraint.
Right.
But Bannister didn't benchmark against his competitors. He benchmarked against the impossible. He pioneered a new standard by relentlessly shaving off just small fractions of a second, analyzing his stride, his breathing, step by step, until he broke it.
And then once he proved it was possible, the paradigm shifted and a bunch of other runners broke it right after him.
Exactly.
But, okay, to achieve a Bannister-level breakthrough or a Toyota-level clinic, a team needs actual tools to diagnose the friction in their workflow. Like, they can't just guess what's wrong.
No, guessing is how you waste millions of dollars.
Right. And the sources dedicate a massive amount of real estate to this ultimate quality toolkit. The 7 basic tools and the 7 new tools.
Which can sound a bit dry on paper.
Yeah, I want to get away from just listing these out like a textbook and actually look at the mechanics of a few. Like, here's where it gets really interesting for me. Let's look at the cause and effect diagram, the fishbone, combined with the 5 whys technique.
Oh, the fishbone is brilliant because it forces a team to visually separate superficial symptoms from the actual root causes.
Right, because human nature makes us want to solve whatever the immediate pain point is.
Absolutely. And the texts give a great real-world example from the automotive industry. So a car manufacturer started getting terrible feedback from drivers, and the complaint was the seats in this model are too low.
Right. And if you're an executive just casually looking at that feedback, your immediate reaction is to call engineering, spend millions of dollars, and literally redesign the seat track to sit 2 inches higher.
Obviously, symptom, seat is low. Solution, raise the seat.
Which would have been a catastrophic waste of capital.
Totally. So instead, they use the 5 whys to trace the spine of the fishbone diagram. They asked the drivers, okay, why does the seat feel low?
And the driver said they couldn't clearly see the road edges.
Right. So why? Because their line of sight was obstructed laterally. Why? Well, it turned out the seat height was mathematically perfect for the steering wheel and the pedals.
The actual root cause was that the design team had built the side window ledges on the doors much higher than normal.
Yes, it created an optical illusion.
Huh.
It made the driver feel like they were sitting deep in a hole.
It's just such a perfect example of how easy it is to flawlessly execute the completely wrong solution. If they hadn't mapped it out, they would have raised the seats, the driver's knees would have been hitting the steering column, and they still would have felt boxed in by the windows.
Exactly. So you use the 7 basic tools like the fishbone or control charts, which measure statistical standard deviations to predict when a machine is drifting out of calibration.
Before a defect even happens.
Right. You use those to diagnose physical reality.
Okay, but those 7 basic tools are quantitative, right? What happens when the problem isn't a physical defect you can just measure with a caliper?
That's where the second set comes in. In the 1970s, a consortium of Japanese engineers realized they needed a different set of tools for non-quantitative planning.
The 7 new tools.
Exactly. Things like affinity diagrams, tree diagrams, activity network diagrams. These are designed to take messy, unstructured human ideas, group them logically, and map out incredibly complex future projects.
So they support innovation before the quantitative data even exists.
Precisely.
Okay, so let's check in on our theoretical broken system. We've got the right KPIs, we've benchmarked our goals, we have our fishbone diagrams to find the root causes.
They're doing good.
Now, we need a unifying operating philosophy. And in operations, all roads lead to lean and just-in-time, or JIT.
Lean is the relentless, almost militant removal of waste to maximize value for the customer.
Right, like Henry Ford might have invented the concept of flow production, but his system was super rigid. I mean, the old joke is that his customer service strategy was, you can have any color Model T you want as long as it's black.
Right. Highly efficient, but zero flexibility. Toyota looked at that and built the Toyota Production System, or TPS, to inject flexibility into that flow.
And to understand TPS, you have to understand its mortal enemy, which is waste.
In Japanese, it's categorized as muda, mura, and miri.
Okay, break those down for me.
Sure. Muda is direct waste. There are 7 deadly wastes, plus an 8th, which is the waste of unused human potential and employee skills.
Love that they include that.
Yeah, it's important. Then mura is inconsistency or unevenness in your workflow. And miri is overburdening your people or your machines to the point of literally breaking them.
And the texts make it incredibly clear, out of all of these, overproduction is the absolute worst.
Because overproduction hides all the other forms of muda.
Exactly. If you overproduce, you have to store the excess, which is the waste of inventory. And you have to move it to a warehouse somewhere, which is the waste of transportation.
It just cascades.
It really does.
Yeah.
And this brings us to the quote from the Japanese engineering guru Shigeo Shingo that is central to JIT. Inventory is evil.
Inventory is evil. It's a strong statement.
It is. And I want to play devil's advocate here for a second, because we have all lived through recent global supply chain collapses, right?
Oh, definitely.
A single ship gets stuck in a canal or a pandemic hits, and an entire industry is just shut down for 8 months because no one has any backup stock anywhere. In a modern, highly volatile world, doesn't the idea that inventory is evil sound a bit fragile? Isn't a safety buffer completely necessary for survival?
It's funny you ask that because it is absolutely the most common critique of lean. But it really misunderstands the fundamental mechanism of JIT.
How so?
Well, inventory isn't just a buffer against global shocks. 99% of the time, inventory is used as a buffer against internal incompetence.
Oh, wow. Okay.
Lean views inventory as a liability because it acts like water in a river. If the water level is really high, it covers up all the jagged rocks at the bottom.
And the rocks are the problem.
Exactly. The machine breakdowns, the poor supplier quality, the absenteeism. The boat sails smoothly over them, but the rocks are still there.
So the moment you lower the water level, the moment you remove that safety stock, your boat immediately crashes into the rocks.
Yes. And that crash is intentional.
Wait, really? You want to crash?
You have to. When you operate a pull system where you only produce a single item when the customer downstream actually demands it, syncing perfectly to the takt time or the heartbeat of customer demand, you have no backup parts.
Right.
So if a worker receives a defective widget, they can't just toss it aside and grab a spare from a massive bin next to them. The entire assembly line instantly stops. This is the pillar of Jidoga, intelligent automation with a human touch. When the line stops, it forces the entire organization to swarm the problem, use those fishbone tools, and fix the root cause so that specific rock is permanently removed from the riverbed.
Because if you have extra inventory, you never fix the problem, you just work around it.
Exactly.
And to ensure those rocks are actually visible, Lean relies heavily on the 5S system, right? Sort, simplify, scrub, standardize, and sustain.
Yes, 5S is crucial.
And scrubbing isn't just about having a clean floor for aesthetic reasons. It's literally an operational diagnostic.
Right, if you scrub a machine spotless every single shift, the second a microscopic oil leak starts, it stands out like a beacon.
Visual management exposes waste before it becomes a massive failure. You organize the workspace so flawlessly that abnormalities have nowhere to hide.
The visual of the house of Toyota really brings this all together perfectly. The foundation of the house is Haijunka, which is operational stability and load leveling.
Right, because you can't build a system on chaos.
Exactly. Once the foundation is stable, you erect the two pillars we just discussed. First, Jidoka, which includes techniques like poka-yoke to physically mistake-proof processes so humans literally can't make errors.
Like a plug that only fits in the socket one way.
Exactly. And then the second pillar is just-in-time production.
Okay, so applying Lean makes our hypothetical system flow really smoothly. We've stripped out the muda, we're pulling to takt time, the water level is low, but flow isn't enough if the product itself still has variations, right?
Right, and that is where Six Sigma steps in.
If Lean trims the fat and makes the process fast, Six Sigma chases absolute mathematical perfection to make it flawless.
And the tolerance in Six Sigma is almost frighteningly strict.
Yeah.
The goal is to achieve no more than 3.4 defects per million opportunities.
Which is what, 99.9997% defect-free?
Yes. And it's crucial to understand how broad the definition of a defect actually is. A defect isn't just a broken microchip on a motherboard. A defect is any instance where a product or service fails to meet a customer's expectation.
Oh, I love the ATM analogy the sources use for this. It really proves that Six Sigma applies to the total customer experience, not just factory widgets.
Walk us through it.
So when you walk up to an ATM, your expectation isn't just, I get money. You actually expect 4 specific things. The machine has to be online, the interface has to be intuitive, the line has to be short, and the cash dispensed must be exactly right.
Right.
If you get the right money, but you had to wait 20 minutes in the rain because the software was lagging, you, as the customer, consider that experience a failure. So a single visit to an ATM actually presents 4 distinct opportunities for a defect.
And when you extrapolate that across thousands of customers a day, achieving 3.4 defects per million requires incredible rigor.
And the mechanism for achieving that rigor is the DMAIC method, right? Define, measure, analyze, improve, and control.
Yes. And what is truly powerful is when you integrate the speed of Lean with the precision of Six Sigma.
Oh, the Navy case study.
Yeah. The Navy case study. They had this J&A justification and approval sole source contracting process. It was a notoriously sluggish, bureaucratic nightmare.
Typical government paperwork, right?
Basically. But they didn't just tell their staff to work harder. They applied Lean Six Sigma.
Right. They used Lean to attack the waste first. They mapped out the entire value stream of this administrative process and realized half the steps were completely unnecessary. They slashed the total steps from 26 down to 13.
They literally cut the red tape in half.
Yeah.
But even with only 13 steps, the paperwork was still getting rejected and kicked back for minor errors. So they applied the Six Sigma DMAIC framework to those remaining steps.
To hunt down the errors.
Exactly. They hunted down the root causes, the missing signatures, the vague justifications, and they implemented controls. They found 17 different redo loops in the workflow and systematically engineered them down to 0.
From 17 to 0. By combining Lean's flow with Six Sigma's accuracy, the total cycle time for the Navy's contracting process dropped by a staggering 50%.
It's amazing what happens when you combine the two.
Okay, so let's check in on our theoretical broken system again. We're measuring the right strategic KPIs. We've used our 7 tools to dig past symptoms and find root causes.
Yep.
We've built the house of Toyota, pulled our inventory to customer demand, and used Lean to strip out the waste. We've deployed DMAIC and Six Sigma to get our error rate down to 3.4 per million.
That's pretty good.
We have the ultimate frictionless, perfectly flowing system. We have won the game of operations, right? We're done.
Not quite.
Wait, really? What's left?
Because even if you are Lean and Six Sigma certified across the board, your system still has a hard, physical maximum speed limit.
Ah.
And that brings us to the final piece of the operational puzzle, the theory of constraints, or TOC, which was developed by Dr. Elio M. Goldratt.
And the central thesis of TOC is really humbling. No matter how perfect your system is, it has at least one constraint.
There's always a bottleneck. Always.
And the maximum throughput of your entire multi-billion-dollar enterprise is dictated entirely by that single slowest point.
Goldratt established a really clear 5-step framework for conquering this.
Let's hear it.
Step 1, identify the constraint. Find the bottleneck. Step 2, exploit it.
Which doesn't mean spend money on it yet, right?
Exactly. It means ensure that specific machine or person never, ever stops working. If they go to lunch, someone else tags in.
Got it.
Step 3, subordinate everything else in the entire system to that constraint. Step 4, elevate the constraint. This is when you finally spend capital to buy a second machine or hire more staff to widen the bottleneck.
And step 5.
Repeat the cycle, because the moment you break that bottleneck, the constraint automatically shifts to a new location in the system.
It just moves down the line.
Yep.
Yep.
And the mechanism they use to control this flow is called drum, buffer, rope.
Oh, okay, I love this visual.
Yeah. The bottleneck acts as the drum. Its operational speed literally beats the rhythm that the rest of the factory must march to.
And the buffer.
The buffer is a highly controlled pile of inventory placed exactly in front of the bottleneck and nowhere else to ensure it never, ever starves for material.
And the rope is just an information signal, right? Tied from the bottleneck back to the start of the line, pulling materials into the system strictly at the pace of the drumbeat.
Exactly.
Now, conceptually, this is where highly aggressive traditional managers really struggle. Like, the instinct of a floor manager is to look at a workstation and say, I want that machine running at 100% capacity as fast as humanly possible at all times.
Oh, absolutely. That's the old way of thinking.
So why would you purposefully throttle down the speed of workers who aren't the bottleneck? Doesn't slowing them down hurt your overall efficiency?
It feels incredibly counterintuitive until you look at the macro picture. The sources use a traffic jam analogy that perfectly illustrates why optimizing a non-constraint actually destroys value.
Okay, lay it on me.
Imagine a really busy highway where 3 lanes suddenly merge into one. That single lane is your constraint.
Right.
If you press the accelerator and speed up all the cars before the merge, you don't get more cars through the bottleneck. All you do is create a massive, tightly packed queue of idling vehicles waiting to get in.
Which, in business terms, is a massive pile of expensive unsold inventory just sitting idle on your factory floor, tying up cash.
Exactly. And on the flip side, if you speed up the processes after the constraint, it's like cars speeding away from the merge.
Oh, I see. Those downstream workers are just going to finish their tasks in record time and then just stand around with their hands in their pockets, waiting for the bottleneck to slowly hand them the next piece of work.
Precisely. You are burning energy, paying wages, and wearing down machines in areas where extra speed literally generates 0 extra revenue.
Wow.
You absolutely must subordinate the ego of the individual departments to the drumbeat of the entire system's constraint.
It is a profound paradigm shift.
Yeah.
You just cannot optimize the individual parts without deeply understanding how they interact as a whole.
It's the only way it works.
So, to bring our journey full circle and sort of summarize this ultimate toolkit for you, the listener, you do not run an operation on assumptions. You start by identifying the few strategic KPIs that actually matter.
Right.
You rely on both quantitative and qualitative tools to separate the noise of symptoms from the reality of root causes.
The fishbone.
Exactly. You benchmark against the absolute best, even if they build cars and you heal patients. You apply lean to relentlessly trim the fat, expose the rocks in the river, and pull inventory.
Yep.
You layer in Six Sigma to hunt down variability and drive errors to statistical 0. And finally, you embrace the theory of constraints to locate your bottleneck, subordinate your entire enterprise to its drumbeat, and break through to new levels of performance.
I mean, it is the definitive blueprint for operational excellence. But, as we close out today's analysis, there is a final kind of provocative thought that emerges from all this source material. Well, we've spent this entire deep dive discussing how to optimize physical workflows, right? Removing tangible waste, mistake-proofing human administrative processes.
Right. All very human-centric.
Exactly. But we are rapidly approaching a horizon where artificial intelligence and robotics are fully integrated into the floor.
Oh, wow. Yeah.
When algorithms can automatically calculate real-time takt time, dynamically shift the drum buffer rope signals, and execute the DMAIC process flawlessly in milliseconds, those physical constraints will largely evaporate.
That's a wild thought.
It is. And it raises an incredible question for you to explore on your own. When the machines inevitably run the perfect lean Six Sigma supply chain, will the ultimate bottleneck, the final constraint holding an organization back, simply be the limits of human imagination and innovation?
Oh man, that is a brilliant concept to take with you. It turns out popping the hood on the engine room of business and analyzing the rigorous math behind the magic doesn't kill the wonder at all.
Not at all.
It just hands you the wrench to build it yourself. Thank you so much for joining us on this deep dive. Keep asking those five whys and keep pushing for that continuous improvement.